Operations with complex numbers just means you're going to be adding, subtracting, multiplying, and dividing complex numbers. And complex numbers are in the form a plus bi, where I is just another name for square root of -1. So if I'm going to add or subtract complex numbers, I'm going to treat this I sort of like a variable and combine like terms. So I need to distribute the negative. There's nothing in front of this parenthesis, so I can just go ahead and add 3 plus 2i minus 2 and a -1 times -i positive 1i. You don't have to put the 1 in front of the I, but you'll see here in a minute why I did that. So from here, combine like terms, the real part with the real part, 3 minus 2 is 1, positive 2i and a positive 1i give me a positive 3i. That's a plus sign there. All right. So that's subtracting. Addition, much the same way. You're only distributing a positive one and then combining like terms. If I'm multiplying, you'll notice there is no sign between the parentheses. It's a parenthesis right next to another parenthesis. So with a problem like this, when I have two terms times a two-term problem, I'm going to use the FOIL method, which is just an acronym for first times first. So 3 times 2. 3 times -i. 2i times 2. And then a positive 2i times a -1i is -2. And then it's going to be I squared. Multiply like bases, add the exponents. So from here, I can combine my like terms in the middle. This is 6, -3 and a positive 4 is a positive 1i. And then a -2. And another name for I squared. If I is the square root of -1, then I squared, if I square both sides, is going to be just -1. The radical cancels out. So when I come down here and say -2 times I squared really is just the number -1. And I can substitute that in. So now I have 6 plus 1i. And then the -2 times -1 is positive 2. So this results in an 8 plus I. For division, it looks much the same way. So if I take 3 plus 2i and divide it by 2 minus I. Now you're not allowed to cancel pieces out. And keep in mind, the I is a radical. And usually we want to get rid of radicals in a denominator. It's called rationalizing. So to rationalize, I'm going to multiply by the conjugate of the denominator. Conjugate just means same numbers, but the opposite sign. So if this is a minus, this becomes a plus here. And whatever I multiply the bottom by, I do the top as well. So on the bottom, I'm going to multiply it out, and you're going to see why we picked conjugates here in just a second. If I FOIL this out, 2 times 2 is 4, positive 2i. But then when I take the -i times the 2, notice it's going to be the opposite sign, -2i. Negative times positive I. Negative times positive is negative. I times I squared. Let's keep working with the bottom here, the denominator. So I have 4. The positive 2i and the -2i cancel. I still have this minus sign. And then another name for I squared is -1, which means I got the I out of the denominator, or I got the radical out of the denominator. I can still simplify this, but before I do that, I'm going to fix the top here as well. I'm going to multiply that out. So again, FOIL, 3 times 2, 3 times I. positive 2i times 2, positive 2i times positive I, that's going to give me a positive 2, and then I times I squared. So on top, I have 6 plus 7i. When you add like terms, you just add the numbers in front. Don't do anything with those powers. And then I have a plus 2. Take out the I squared, put in the number negative 1. Now let's go ahead and simplify the whole thing here. So I have 6 minus 2. And then I still have my plus 7i divided by 4 minus a minus 1 is 5. Now if I want to write this in a plus bi form, I want two separate terms. Right now this is one big giant fraction. So I'm going to split it up. And then see if you can reduce any of these little fractions down. If you can't, this is it. So to recap, multiply top and bottom by the conjugate of the denominator, FOIL it out. In the end, your denominator shouldn't have any i's in it. Multiply out the numerator, combine your like terms up, and then split the fraction up.